KPCL. The leading power corporation of the state, supplies 80 million units of power to the state daily. BTPS, which has the highest capacity unit-wise in KPCL, delivers 24 million units of power on daily basis. Thermal power station works like a living body. Operation is the brain of the power station. Mechanical system, the skeleton of the power plant. Electrical system is the blood. Instrumentation and controls, the nervous system of the plant. Chemical system maintains and treats the fluidic balance of the plant. The interaction and coordination of all these systems generates the power 24/7, continuously. Suffering of one equipment cripples power generation. Failure of any one of these systems halts the power station. On March 17, 2013, BTPS Unit 1, 500 megawatt power generating station, suffered fire in the cable vault. Thick smoke engulfed operation control room, affecting operation personnel and control panels. Monitoring the parameters was difficult, as the smoke covered makes it impossible, even to view, at 2 meters distant. Breathing got difficult, due to lack of oxygen. Control room and cable vault was covered with the gases of fumes, acidic in nature, liberating from the PVC component of the cable insulations. Control room engineers have to break down the glasses to come out of the control room. Down the stairs, fire personnel find it difficult to enter the cable vault. Thick smoke was restricting them to enter into the cable gallery. Irrespective of the cadre, all the engineers and technicians grouped together with fire personnel to enter and set off the fire. They broke open the other door and started to cease fire. Fire personnel tried with carbon dioxide foam to put off the fire. The fire was so intense that it took almost more than 1 hour to set off the fire. As a result of the fire on the cable insulations, all the cables are joined together, makes it difficult to identify individual cables. At this time nobody was aware that part of the nervous system of the power plant automation is burning beneath the unit control room. There were 6 cable trays, all of the cables in them were burned. Total power supply to the unit has to be shut down, to allow fire personnel to use foam and water to set off the fire. As the compressor cooling system of the Unit 2 was on the control of the Unit 1, shutting down of the Unit 1 had affected Unit 2 also. Both the units were halted. Instrumentation engineers rushed to the spot and find the parameters relating to the generator auxiliary system and furnace safeguard supervisory system seriously affected. Some of the process control system, protection and interlock system of the equipments were also affected. Total power plant automation control system was switched off. The systems related to the bearing gear, generator auxiliaries, and air preheaters retained. Operation personnel have to rush to the local spots to ensure the status of the emergency systems. Some of the control panels have already affected, with the secondary effects of the fire. In the cable vault, out of 6 cable trays, 3 bottom perforated trays carries control cables. All of them were burnt badly. This was the first of its kind emergency to the instrumentation engineers. They estimated about 900 cables of the bottom 3 perforated trays were badly damaged. Part of the nervous system of the power station got hurt. The power plant automation system was in ICU. It was the rarest of rarest case in the history of power plant automation. Instrumentation engineers had a very challenging task on them, to repair the badly damaged nervous system of the plant. As it was the summer and exam season, the state was badly in need of the power. Engineers expected the pressure on them to regain the unit at the earliest. Now, to tackle the emergency situation, and to regain the unit, they have to chalk out the plan to regain the automation system, at the earliest possible way. Works have to be carried out on a war foot. They found 3 ways to rectify the problem. 1. To lay new cable from control panel to the field. 2. lay the cable from control panel to the fire affected zone, and join the respective end of the cable. And the third, replacing only the burned out part of the cable with new one, and join the cable at the respective ends. Task number 1, to lay new cable from control panel to the field. Needs to identify the services first. List out the type and length of the cable from control panel to the field. This process requires a minimum of 10 days. Placing the order for the procurement of cables requires a minimum of 7 days. The supply of the cables from the supplier, depending on the availability, requires a minimum of 15 days. Altogether, getting the fresh new cables at site requires a month. Laying of new cables and commissioning of the automation system requires another 15 days. Getting back the unit in 45 days with new cables will still be a more challenging. Task number 2, laying of cables from control panel to the fire affected zone. This also requires to identify the services first. This requires 10 days. Getting the cables requires a minimum of 7 days. Laying of new cables and commissioning of the automation system requires another 12 days. Altogether a minimum of a month. In this emergency situation, engineers decided to go for a third task, that is replacing only the burned out part of the cables. They estimated a minimum of 20 days. There were 3 priorities in this task. 1. Not to miss any single cable. 2. Ensure perfect joint, and 3. Avoiding cross-wiring. A cross-wiring of one cable would cause 2 cables missed out of their services. They had a plan for foolproof joint at the both ends, by tagging individual cables immediately after the cutting process. They had another problem: the process of cutting, tagging and joining of individual cables would make it difficult in joining the bottom-most cables of the tray. To overcome this, they got an idea of running a new tray parallel to the older one. They also foreseen the problem of cable segregation. Hence they decided to go for a batch process, along with a new tray. The batch process includes all the cables in a particular tray to be cut individually and to be tagged first. Then cables segregation and sleeving out. It is planned to divert half of the cables to the new tray and other half retained in the older one. This way simultaneously 2 cables at the both ends can be joined. Engineers were aware of each cable, that contains around 16 cores, with individual shields for each pair, and a common shield to the whole cable, and all of them are to be joined accordingly. There was no room for the error. Now the question of joining the cables. Soldering, or the crimping process. In the process of soldering, dry soldering leads to continuity problems, due to dragging or other cabling disturbances, during cable dressing. Soldering can be adapted, if the cable after the soldering process, would not be disturbed at any cost. Lack of guarantee for this condition, forced to take a decision on crimping process. KPCL engineers inquired BHEL engineers on site, regarding this process if it has happened anywhere. On receiving a positive note on crimping process, however not at this bulk number of cables, gave the confidence of joining the cables with crimping process. Project execution was carried out with full zeal and confidence as it was a challenging one for everybody. The cable trays were named as Tray A, which is the bottom-most tray, and subsequently B and C. The process of cutting, identification and tagging of cables started on Tray A first. The plan was to finish Tray A first, and then placing Tray B over this, so that cable crimping process will be easier, much faster, and chance of mistake reduces. During the process of cutting Tray A cables, it was observed that identification of armored cables were easy, and the same was very difficult with the unarmored cables. Some of the unarmored cables got cut at the same point. This caused difficulty in cable identification process. Cables were identified on the basis of color of the burned debris. Due to this, the process was running out of time. The unarmored cables in the form of thin paste of lumps become miserable for identification. It was a challenging job for some of the cables to identify. However, all the cables were identified, and cut accordingly. A foolproof method was adapted to note down the tag, type and number of pair or cores of the cables, to tally left-hand side, to right-hand side of the non-burnt old cables. It was observed that all of them were identified correctly. As the process continued, the cables were coming out of the tray like Akshaya. The digging of tray A was not finishing yet over. It was felt that the process of digging earth, for the gold, or the coal, or drilling oil out of seabed, would sounds better than this. At last, 220 cables were cut, identified and tagged accordingly. Everybody was surprised to the number of cables the tray held. Still tray B and C looked overloaded, and this tray were waiting for the engineers to challenge. The confidence of all the engineers started diminishing, as whether they would ever complete the task without a single mistake. A team of higher authorities from the head office, and the technical director of KPCL and other dignitaries visited the site. The authorities inspected the fire zone and astonished. Engineers explained them the condition of the nerves of the unit, and the problems they encountered with tray A cables. The authorities were also informed about the accuracy of joining the cables the engineers dealing with. They also explained them the survival of the corners of the cable trays from the fire, due to the anti-fire resistant coating on the cables. The authorities were also explained about the loading of the future trays B and C. They were informed that the expected cables on tray B and C might be around 600. Engineers informed them that they have to crimp 220 cables from tray A on both sides, and about 600 each cables on tray B and C have to be cut, tagged, segregated and to be crimped on both sides. Engineers requested the authorities, for the time of completion of the project, to a further of 15 days as the tray B and C cables are loaded heavily. Authorities encouraged the engineers, and explained the scenario of the power crisis of the state, and asked the engineers to complete the work as early as possible. They also motivated the engineers to work to their limit to complete this challenging job. Engineers were informed that authorities were arranging the new joining cables from the RTPS. Authorities and technical director of KPCL wished good luck to the instrumentation engineers, and wished speedy recovery of the Unit 1, with 500 megawatt on load. And at this juncture, it was a test for the instrumentation and control engineers, as they have never faced such a type of emergency crisis in their service. Now they had to prove that they have a good team of engineers and technicians to complete the task, without any single cable missing, without any cross-wiring, and without any time delay. They continued to work as a team. They accepted this as a challenge and started working in a systematic way. The support from other departments of mechanical, electrical, chemical and purchase was appreciable. Whole, BTPS supported them morally, to bring back the unit as soon as possible. The support from local BHEL side has also arrived, in respect of cables and cable trays. The cables from RTPS also has arrived. There were different types of cables to be joined. 2 pair, 4 pair, 8 pair, 12 pair, different types of 2 corp, 3 corp, 4 corp, 5 corp, 10 corp, 2 pair thermocouple, different types of 4 pair thermocouple, 8 pair thermocouple, power cables, special type of cables like flame scanner cables and VMS triode cables. As per the plan, before the crimping process, there were a lot of other steps to be completed. Cable identification and cutting, tagging of each cable on both left and right side of the tray, cables segregation, sleeving out the cables, and preparing the new joining cable. The new joining cable is prepared, taking care of identifying the cable type, cutting to the measurement, tagging and sleeving out. New cable tray is laid parallel to the tray A. There were different teams in the process. While one team was crimping, and the other team was preparing a new cable. Both the teams were synchronized. Crimping team placed the order for the new joining cable, and cable team used to supply the right cable, at the right time. According to the plan, another team was ensuring proper cable segregation, diverting the same tagged cables, on old, or new tray on both the sides. After getting the new joining cable with the tag, the crimping team would ensure double sleeves for each core. The crimping process continued as crimping, shield crimping, dressing the cores, cable sleeve dressing, and final dressing on the cable tray. Ensuring the perfect crimping, and avoiding the disconnection, in case of any disturbance on the cable, was the primary task of the crimping team. They had a plan. All the cables were shielded. Hence, after the crimping of individual cores of the cables, the shield wire is crimped with lesser length than the core length, so that dragging or any other disturbance to cable joint would first break the shield wire. Sufficient extra length was provided to the core cables, so that during disturbance, this joint would not cut. With so much precaution and a perfect plan, they had a worry of possible human error while crimping. Team of dedicated engineers supervised and inspected the perfectness of each core, and ensured the right cable and right type is crimped to the right destination on both the sides. It was like a microsurgery. Simultaneous crimping of 6 teams were working on Tray A. In the control room, damage was noticed to the control panels also. Another team of engineers started to rectify the problems relating to the control panels. The control racks were cleaned. The control cards were identified for the damage, and replaced. All the engineers and technicians, working round the clock hard, to achieve 0% error. Now the pressure starts to building up, for the speedy completion of the work. Around 60 cables per day were completing. Possibility of simultaneous work on the other trays too, was explored. Engineers worried about the cables, those would miss if the work starts on the other trays. Handling of 300 cables at the time, without a single mistake, was painstaking. And now they are worried about handling of 600 cables. They foreseen the inconvenience of crimping on the lower trays, if they lay other trays. Engineers wanted to avoid inconvenience to the crimping work on Tray A, and also to work on the other trays too. Hence, they come up with an idea of working on Tray C, leaving Tray B as it is, so that it would cause less inconvenience to the Tray A work. The work on Tray C to be started. But the cutting process of cables on Tray C would cause inconvenience to the crimping team, working on A. Hence cable cutting process would carried out during the lunch, or during the break of the crimping team. Now simultaneous work on both the trays started. New cable tray laid for the Tray C. Everybody expected more cables to be crimped, per day. But the process of segregation, and sleeving out of Tray C cables, could not be carried out, when the 6 crimping teams were working for the Tray A. The space restriction. Hence segregation, and sleeve-out process of Tray C cables, were carried out during the night shifts. Till this time, the numbers per day did not alter. Now also 60 cables per day. Due to the inconvenience for working on the older Tray A, it was decided to route more than the half of the cables to the new parallel Tray A. At last, after the tense and stress of 12 days, sigh of relief. The work on Tray A completed. Engineers and technicians now stretched their limits, and felt that they can speed up the work, as they know the pros and cons of this cable joining process. Now, they have the grip. They have the rhythm. Work on Tray B also started simultaneously with Tray C. And work was on both the trays. Dedicated team of engineers and technicians of both the crimping team and the cables team worked in full swing. Cables team, now able to prepare 16 new joining cables per shift, of 12 hours. Crimping team, now could crimp around 70 to 80 per day for both the trays. The pace of the work picked up enormously. Every engineer, and every technician, enjoyed the pace and rhythm of working. The teamwork was unexplainable. All the engineers and technicians did not want to miss their rhythm. Sometimes it was observed, they did not want to have break at all. The pace and the teamwork was superb. The Josh in them to achieve something was appreciable one. Tray B was holding 272 cables. And Tray C held at 293 cables, which was the highest one. April 3rd, it was the 16th day. 134 cables on Tray B and C were remained. The work started. Pace increasing day by day. The rhythm, pace and the speed made it possible. All the 134 cables crimped in a single day. The job is over. The nervous system of Unit 1 BTPS is restored. The 16 days of hard work, dedication, and the team effort by instrumentation engineers and technicians finished their assigned job. It was a great success. They have completed the task well in advance by a day. Everybody appreciated the efforts. All the engineers and technicians worked to their limits. But this was only the test. Result depends on the accuracy of the cable's continuity. Engineers expected and wished 100% success in their result. The process of testing started. It took around 3 days to complete. It was found that 8 cables had a problem, but all of them solved. On April 7th, the Sunday, exactly after the 3 weeks, Unit 1 synchronized. Each signal is thankful to those whose effort made it possible to reach the signal from its control panel to the field and back. Each signal remembers those whose dedication and hard work, directly or indirectly, made it possible to generate the power to the nation. They have shown the enthusiasm and teamwork which was generated by the motivation, freedom of working, and the good working atmosphere they had earlier, made it possible to take up this challenging job. If these encouragement, freedom of working, and the good working atmosphere are maintained, then nothing is impossible to them in the future.